Our project was actually, we stumbled upon it in research that was funded before this project. And so we were trying to understand the toxicity of and characterize oxidized hydrocarbons that are in the environment. And so when a crude oil, which has very little oxygen in it, is spilled into the environment, it gets oxidized by various mechanisms, photo-oxidation, bio-oxidation, or what's called bioremediation. When the hydrocarbons are oxidized, they change their physical and chemical behavior a lot. And so if you looked on the news, you saw the mousses and thick mats of oil.
Right.
They're not sheens, right, which is what unmodified oil does. But when it starts to be modified, it starts to change its behavior. And so we analyzed a bunch of field samples and discovered tens of thousands of these oxidized hydrocarbons in oil. So they were oil soluble. And of course, we had to characterize the tar that was on the beaches and stuff, and that's the oil soluble, because the water solubles have dissolved into the Gulf of Mexico, right? You're not going to find those. And so when we were trying to understand the toxicity of photo-oxidation and bio-oxidation, we had the opportunity to not only address the water solubles, but we had the oil. So we just started looking at the oil. And the oil soluble OX transformation products from the simulated sunlight matched almost identically to all of the things that we identified in the field samples. And so then we started scratching our heads and we're like, well, wait a minute. Well, what about bio-oxidation's contribution? And so when we isolated the oil after bio-oxidation, we found no oil-soluble OX species. And so then we're like, okay, so we're on to something here. So then we started characterizing the entire continuum of molecules that are formed by photo-oxidation. And we got really lucky. So I do a lot of petroleum work as well. And so we had internal methods that were already developed to isolate interfacial material. And so when we started looking at these transformed products from the solar simulation, we were able to isolate interfacial material. And so these soaps, right? So you've taken a hydrocarbon and you start add oxygen to it. That's how they make Tide and all these other surfactants. But the sun is doing it. And so when it makes these surfactants, they swell with water, and that's what forms these mousses and thick tar mats on the ocean after a spill. So that's what we were out to prove. And so we irradiated a crude oil with sunlight, and using this method that we fortuitously had, boom, we were able to isolate the interfacial material and start to characterize it. But it shines a light on photo-oxidation and says, hey, you know, for surface oil slicks, this is the dominant process that's changing the physical behavior and the chemistry of these materials. The use of dispersants is a huge research theme for GoMRI. It was the first use of dispersant subsea, and it looks like it worked really well. But the next question is okay, they sprayed a lot of dispersants on the surface oil. And was that smart? And how did it work? And are they causing a bigger problem than if they just let it go? And so there's a couple of things that could come out of this research that would have important implications. The first being is that when we look at the toxicity of these photo-generated products, we see that it becomes, in early exposures, that it becomes more toxic than the oil. But then it rolls over and becomes less toxic. And as a petroleum chemist, that makes no sense to me, because the same species that are being formed in the early are being formed in the later. And we have a sneaking suspicion that it's this interfacial material that is controlling what can move from the oil phase to the water phase. And in the early time points, there's not enough interfacial material to really form a stable film. And so we're going to test that. And that would mean that, you know, if this interfacial layer is actually helping you because it's holding back some of the OX species that would go in the water, then you zoom a plane over it and shoot a dispersant on it, you're going to break this interface and you're going to release all that material into the water. Maybe it would be better to look into strategies that are better at skimming and collecting these mousses. So that's important. The next is okay, we're going to have to disperse it because we can't come up with technologies that can effectively skim this thick material. We can isolate the interfacial material in bulk quantities because the method we use is literally dirt simple because it uses sand, another pun. But so it's easily scaled up. So we can make big columns of this, irradiate a lot of crude oil, isolate the interfacial material, and then test dispersants against it. Because maybe a dispersant that's good for the oil is not good for a photo-irradiated oil, right? Because they test it against the oil, they don't test it against the photo-irradiated oil. And so we have collaborations with huge chemical companies in the petroleum industry, actually Nalco itself, who supplied the core exit. So it's definitely a possibility that why are we trying to treat or optimize a dispersant for the material and we test it against the crude oil when what we're trying to disperse is not the crude oil anymore. So in future spills, if we can isolate this interfacial material and tune the dispersant to that material, because that's what you're trying to get rid of, then in future spills, you could quickly get a sample, irradiate it, and test different chemicals against it and say, no, don't use these chemicals, use this chemical. The big thing, I think, is understanding the importance of what process contributes to what material, because you can't really solve a problem until you know who's causing the problem. And so I think the impact of this research is knowing what processes dominate in the formation of material that dictates the problem you're trying to solve. And so it's basic in a sense, trying to understand the chemistry of this process and point to the one that's dominant. But I think the results could be used lots of other places. No, I mean, I think the whole GoMRI process has been spectacular. It's you know, environmental research is never really given, you know, I think the priority it deserves. And you know, I don't really appreciate how we ended up where we did as far as having the resources to get the research done. But we ended up where we did, and I think what's come from it is massive cross-disciplinary knowledge and discoveries that in a database can be used for decades to come. So I think it's been spectacular, and I'm proud to be a part of it.